In this video, we're going to take a look at testing a hypothesis. Now, we established in the first video of this chapter on chi-squared tests how to calculate x squared here. So this x squared, this is our chi-squared value. And as you can also see here, we do use this as our test statistic. So we then established in the previous video how to calculate the critical value using the chi-squared family of distributions. And hopefully you can start to appreciate now how the previous two videos have largely laid the foundations here for hypothesis testing for the chi-squared tests. And what we're looking to do now is to put all of this together here to perform a hypothesis test for a given experiment. Now, in terms of the significance level here of our hypothesis test, this will normally be 5%. Obviously, it could be different. You could have 1%, 2.5%, 10%, for example, but normally you'll see it at 5%. However, the good news is this will always be given to you in an exam, so it's not something that you need to worry about. And then finally here, if x squared, our test statistic here, is greater than the critical value, we reject h0. So if there's one thing that you take away here from this introduction to testing a hypothesis, I want you to take away this very final line here. So again, if x squared, our test statistic, is greater than the critical value, we reject h0. So please do make a note of this here. This is really, really important. So that actually gives us everything that we need here then for our introduction to testing a hypothesis. I do appreciate that this probably feels like quite a quick, maybe even rushed introduction here, but we have already largely, as we mentioned, laid the foundations for hypothesis testing here for the chi-squared test with the previous two videos. So if you haven't watched those already, do go back and watch the previous two videos. So that gives us everything that we need here then for our introduction. Let's take a look now at one practice question here for testing a hypothesis. Let's get started then with this practice question here. So what do we have for this question? Well, as it says here, as part of an experiment, a 6-sided dice is rolled 90 times. The frequency distribution is to be compared to a discrete uniform distribution as presented below. So we've got this table here, and for this row we have the observed frequencies, and then for this row here we have the expected frequencies as well. It then asks us to test at the 10% level of significance here whether or not the observed frequencies could be modelled by a discrete uniform distribution. Now, given that we're testing a hypothesis here, it makes sense to start just by defining our hypotheses here. So we need H0 and H1. So for H0 here, what do we have? Well, in this case, all we're saying here, it's nice and straightforward. We're just basically saying that the observed data can be modelled by a discrete uniform distribution. So let's just start by writing that down then. So the observed data can be modelled by a discrete uniform distribution. Okay. Like so there. So that's all we need here for H0. So we're saying that it can be modelled by a discrete uniform distribution. So for H1 then, what we're going to say here is that the observed data cannot be modelled by a discrete uniform distribution. Okay. So the observed data cannot be modelled by a discrete uniform distribution. Okay. And there we have it. So that's a good start there. Just defining our hypotheses here. So that's H0 and H1. Now we also need two more things here. So I need my chi-squared value. So we need x squared here. So this is the summation then. So the summation here of the square then of OI minus EI. And then we divide this here by EI, the expected frequencies. Okay. So let's just define a new row here underneath my table. So this will be OI minus EI. We square that here, and then we divide by EI. Okay. So for example, then we do 14 minus 15. We square that, so we're going to get 1 there, and then we divide by the expected frequency here of 15. So we get 1 over 15 to begin with. 1 over 15 there. And let's just keep going here. So 11 minus 15, that would be minus 4. We square that, so we're going to get 16 there, and then we divide by the expected. So what I'll do here is I'll just give these as I go. So 16 over 15 there. So this one here, this would be 9 over 15. This one here will also be 9 over 15. This one here will be 4 over 15. And then finally here, this would be, this will also be 9 over 15 there. Okay, so 9 over 15. So basically now we just sum these values here. So 1 over 15 plus 16 over 15 plus 9 over 15 and so on and so on. So they're all over a denominator of 15. So it's just 1 plus 16 plus 9 plus 9 plus 4 plus 9. And this is all over then 15. Okay, so let me just double check. I've got all the values here. So 1, 16, 9, 9 again, 4, and 9. Perfect. And if you evaluate this here then, what you should find is you get 3.2. Okay, so we get 3.2 exactly there for our chi-squared value. And this here gives us our test statistic. Okay, now what we also need then is the critical value. So we need our chi-squared family of distributions now. So what do we have then? Of my chi-squared distribution here, okay, how many degrees of freedom do we have? Well, we've got 6 possible outcomes here, 1, 2, 3, 4, 5, and 6, and we have one constraint here. That is the total number of rows. So my degrees of freedom is going to be 6 minus 1, okay? So our new value here is 5, and then in terms of the significance level then, well, we're given that here, that is 10%. Remember, you will always be given this in an exam style question, okay, or an exam question as well. So 10% here. So to obtain the critical value here, then we need to refer to our formula book. So if you have it to hand, that's great. If not, I have also snipped this excerpt here of the formula book. Okay, so feel free to use this if you don't have one to hand. So this V here, it's not a V, this is the Greek letter nu here, and that tells us how many degrees of freedom we have. Well, we have 5 degrees of freedom here. So we're going to be in this row here then. Okay, like so. And we have a 10% level of significance. Okay, so we just keep going here until we get to the 10% level of significance, which is this value here. Okay, so let's just circle that there. So we get 9.236. Okay, so 9.236 there. Okay, and what we do now is we compare this chi-squared value, our test statistic, to our critical value here. So in that case then, 3.2 is less than 9.236, hopefully quite obvious. That's less than 9.236 there. And in that case then, what we do here is we accept H naught. Okay, so what we're going to do then is accept H naught. So we accept H naught here. So what we're going to say here then is we have insufficient evidence at the 10% level of significance to reject H naught, and from there we can conclude that the dice is not biased. Okay, so insufficient evidence. This is always the worst part of any hypothesis test, the lengthy conclusion. So insufficient evidence at the 10% level of significance. Significance here to reject H naught. Okay, so to reject H naught here, and therefore we can conclude, so we can conclude here that the dice is not biased. Is not biased there. Okay. And there we have it. So we finally got there, but that gives us our conclusion. And that actually gives us the solution then to this practice question here. And that actually brings us to the end of this video on testing a hypothesis.